Okay, so we didn't quite get to activity 5 last time because I wanted to separate that out for you. We're going to compare individual resistances and how it affects the current through a circuit. So I've got one loop, it's doing this. If I put a second loop of a long bulb, that cuts the resistance in half, and we see, wow, that's a big change in the amount of current going through there. Okay, so we can see the deflection happening on the needle up here. Now let's put a second loop that's around a bulb on the side. Look at how much extra current we got going through there. So it still powers the long bulb and it still powers that round bulb. Look at that. Huge amount of current. But you know what? It's more fun to do more. So let's leave this one hooked up. And let's add one more round pathway. What? Is that even legal? Can you do that? Let's find out. Hold on. Everybody got their safety goggles on? Okay, here we go. What? Okay, we should do more. So the more pathways you have, the more current can flow. And this is actually how things work in your house. You can have all these things hooked up. For example, you might notice that your, say, toaster or oven or, say, computer or your blow dryer all have little two-pronged plugs like this. And so when you plug them into the wall, all you're doing is just doing this and adding one more thing, adding it on to everything else that's already going on. If you plug in too many things, could too much current go through the wire? Absolutely. And if you put too much current through the wire, you have your wires catching on fire inside your walls, and that's bad. And that's why they have circuit breakers that measure how much is going through here, and they shut off. So there you guys go. Now you kind of have a basic understanding of how the wiring inside your house works. Is everything's wired in parallel, so you can plug things in and unplug them at your will without causing problems to the other things that are out there. But you do have to be careful not to overload the wires in your walls, especially older wires that are thinner, because they might get a little bit hot and catch on fire, as we saw earlier when we were playing around in the simulations. All right, guys,